Hey everybody, hope you're all doing well today. Finally, it's Friday. Well, yeah, this week has been a bit of a difficult one. Well, not difficult, but it's pretty busy. Well, there's lots of stuff going on, but I think I'm ready to do some programming for sure. Oop, no reason to leave this open. Alright, so what I was doing yesterday was, okay, well the main goal, unfortunately the game is not runnable right now apparently. Okay, oh yeah, I don't need this function, so maybe I can run the game. Kinda, what I want to try to do is smooth the normals on the edges of sections in the terrain, so that we'll get some smooth lighting. Right now the terrain looks kind of flat, and where there is actually any lighting, you get these like very crisp edges, which doesn't really match the feel of the rest of the game. Yeah, so you can kind of see it right here where we get a little of the rim light. What I ideally want to happen is there'd be a bit of a smoother edge here. Unfortunately, to do that, it's been quite an ordeal, but so the difficult thing is that since I broke the terrain into sections, they don't really know anything about the other sections around them. And in order to have them know about their neighbors, it's been a little bit difficult because, well, I just had to figure out a way how to store all that data. So what I came up with was that whenever a section is created, it will basically register itself as being parented to a specific position on the map. And then whenever a cell needs to find its neighbors, it will just look at all sections dealing are parented to that position on the map, and then from there it can what's the word? That from there I can figure out where its neighbors would be. So like for this one, well, this one's pretty easy because I can just look on the neighbor or on all cells parented to this position, all sections parented to this position, and then it would find any margin tile, and then it knows that that's the neighbor. But let's say for this neighbor, it would need to look at cells here, are parented here, and cells parented here, and then it would pick out the hexagon from each, and then it would need to find the triangles. So it could use either cell for that because these are parented to both of them. So that's the idea. And that's what this placement registry deals with. So whenever you create a section, it just adds it to a parent cell, side chunk index, and a section index. Okay, and right now it's actually very, I don't know. Yeah, I don't think this list, well, it'll be fine for now, but later on we'll probably need to optimize this into at least a dictionary that takes an factor 2 of chunk index and cell, because otherwise everything is gonna have to loop through every entry in this list, and this list is gonna get pretty big. Because I think our terrain already has quite a bit of sections. Let's see. Yeah, so we have 88 sections, and that's just on the first chunk. So that means we have, I don't know, somewhere around 400. And then each of them also has, or enters itself into the registry multiple times because the margins have multiple parents. Yeah, so that list is going to be pretty large. Maybe around 1,000 or something. And every... Yeah, we're gonna have to loop through it multiple times to find all the parents, so... But I guess I can fix that later. Or is it even worth it to use this specific... Okay, actually... Okay, yeah, let's go ahead. I know that this is already gonna be slow. And it's not really that much difficult, or that much more difficult to change this to a dictionary. So it'll be a vector2 int. Oops, accidentally pressed cap lock apparently. And now the entry doesn't really need to contain the chunk index or the cell. Okay, let's comment that. So keys x equals chunk index and... Oh, well, I don't even need to do that really. I can just... Yeah, because there's... Yeah, I can just do it just by integer, just by the cell. Yeah, so that's... makes it a little easier. So, yeah, the keys are the parent cells. Okay, so first we'll need to get the list. Okay, so if state placement cells try get value cell. Okay, and if this is false, then we'll need to create a new list. Let's do it this way. Also, right here when we first run, I should clear this. So that we don't have stuff left over if we have to regenerate the terrain. Okay, and then I just don't need to even put that. Okay, so that makes things a lot easier because now we can just search in a dictionary for a specific cell. And each cell would have, I don't know, probably... Well, I guess I do know exactly how many entries it would have. It would have the hexagon plus 6 margins plus 6 triangles, so 13. So, I mean, that's fine to loop through. Okay, so what is the next step? Somehow, let me see here. Why don't I work backwards from the normal generator? Oh, I don't know. Let's see. So the normal generator needs to kind of have this twins for a specific section. And again, maybe this should be a dictionary where I can key it by the point index, and then we would get some value like that. Oh, I don't know. It doesn't really matter at that point. But what this twins is supposed to do is it gives us a point in some neighbor that is identical or that has the same position as one of the points in this section. And the reason we need to do that, or need to know that, is because then we would have to add triangle, or add the normal from any triangles connected to that twin. But I don't know. Let's see. I don't think this would actually be useful. How does the normal system work right now? Because, yeah, I think how it works now is it just loops through all the triangles. It doesn't actually care about the point. So I think all I'll really need to do is know... Yeah, because I can't use just the normal for that specific position. That's our twin, because the normal... is... what am I trying to say? The normal... could not have been generated already, and so... And anyway, it would have already been, okay, well, this is kind of confusing. The normal would have been normalized, or turned into a unit vector, so we would have lost the weight already. So, let me see. Okay, so basically, yeah, this will need to know our neighbors. I think we would find all of the triangles in our own section, and then we would loop through a neighbor, but only add triangles if they have a twinned point. Then we would add that triangle's cross product to the point in this section, or I guess the parent section. That was a twin to the point in the neighbor section. So what I really need to do is I need to have a list of all of this section's neighbors, and then I need to have a map that tells me the twins from the neighbor's perspective to my index. Okay, so I could build that easily if I had this. I could build both of those easily because I would just add all these section index and chunk indexes to a hash, and then I'd know all the neighbors. And then I could build an individual dictionary for each of them that would basically map from this point to this point. I think that's probably the best thing to do. So, okay, so since I have this, I can find out all of my neighbors, or neighbors of a chunk, pretty easily. I would just, again, just look in the parents depending on what type I am. And then I would want to find any of my twins. So that would have to be done. Unfortunately, I don't think there's really an easy way. I'll just have to, like, do every type of pair. Okay, so let's go ahead and do that. I guess... I mean, that's kind of 2 jobs, but... maybe... I guess I'll just start off putting it in one system, but if it's a little bit too complicated, I can separate it into one system that finds the neighbor sections, and then another system that calculates the twins. Okay, so point twin generation system. Alright, I usually like to copy another class as a starting point. I guess I'll do... this one's actually more complicated. No, that's on the template. Okay, positions will be fine. Okay, so again, first step is I need to find all the sections that are my neighbor. Yeah, you know what? These are like two separate things, so let's... because I'm gonna have to store them in an array anyway. Okay, so this will be section neighbor. I guess I'll just... doesn't really generate them, but... okay, so I guess if this... well, I'll just add an array of... it's not a... it'd have to be a vector2 int. And it would just have the chunk index and the section index. So neighbor sections. Oh, it's supposed to be in a comment. Okay, and the nice thing is that since... okay, I just thought that the normal system would have to wait until basically all the sections had been generated already, but the nice thing is that in order to... well no, I do need to know the positions, don't I? Yeah, so I just have to wait until all the positions are generated for every section. Okay. We'll need a couple more states here. That's neighbor sections. And S twins. Okay, so there we go. I got the main thing set up. So, okay, we have to... this doesn't need the templates for anything, I don't think. It just needs to know... what does this need to know? It just... okay, it needs to know its board index. Or does it even? No, I don't think it does. So really, it can run right away. Just as long as the neighbor sections is waiting. Because all it has to do, we need to switch based on the section type. And then depending on what type it is, we would just look at our neighbor list and then pick out specific sections as that we care about. So let's say find for hex. Okay, so how I'll do it, I want to sort these. Let's create a list of the... what is it called actually? Yeah, placement registry entry. Is that how I should do it? I might need to create another class actually to use for sorting. Struct, found, or let's just call it a neighbor. The problem is that this entry doesn't contain the cell index, which we'd probably want to use to sort. Because I want to place the neighbors in a specific order into this array so that the next system will already know which index specifically is a specific neighbor. Is that a good idea? Because... Okay, well, yeah, that's fine. I was gonna say, because like on the edge of the world, you might have... I mean, that'd be a different type of section, but it's still... that specific... Okay, I'm just trying to think. Should I encourage that, or will there ever be a reason why, or a possibility that the list of neighbors could have a different order? If I look on the terrain. I'm trying to think, I don't know if there's any time that would actually happen. But if there ever was, I guess I could have a flag or something. So, two variations I know of right now that's not implemented is like the edge of the world, but that would still just be a rectangle and then a triangle, so that's no big deal. They would just be shaped differently. And then here, if there was a stone tile underneath that I wanted to show, but that wouldn't affect these neighbor points, which is what we care about. So I think for now, I'm safe doing it, having a specific order. But if at some point that order ever is variable, I guess I could have, I don't know, some field here that's like private. Or it would be like an enumeration that would say the neighbor order or something. I don't know. So this should be fine though. Anyway, back to what I was doing. I want to... Basically, this is going to be the old entry with the parent cell. Then I'll have a list of this. Neighbors. And then I'll need to have a bunch of sorting functions for it. So private static void sort hex neighbors. Okay, actually it's not a void, it's an integer. Because if, yeah, this is positive, that means that A should appear after B in the list, and if it's negative, that means A should appear before B in the list. If it's 0, that means they're roughly equal. So I think how I want this to work is if, okay, I actually can't make this static because I need to reference the state because I'll have to get the types of the neighbor sections. Because I want them to be organized by side, so northeast first, and then it goes clockwise. And I also want all the rectangle margins to appear first, and then the triangle margins to appear after. Okay, so that means I need to get the section type. State chunks a chunk section index. Oh, okay, I think I forgot something. Okay, yeah, the type. Then I'll do the same thing for B. Um, okay, let's actually wait to sort, because I just realized I'm going to have to pull this type out. So why not just store it in the structure? So that way I don't have to do this again. Okay, so I'll just return 0 for now. Okay, so anyway, we really only care about the list at our specific cell, because all of the neighbors should be parented to this cell. So entries, and then the view section. Oh, not section. State. Placement, cells. Okay, and then I have my cell, don't I? Okay, I call it hex index here. I guess I'll change this back, because again, a hex also implies altitude. Okay, so now that I have that, I guess I could just add this entire thing to our list here. Or hexagons anyway. Oops, forgot the N keyword. Okay, so if entry dot type, oh, that's not how, yeah, we don't have the type from this. So I guess I do need to get the type because, yeah, we'd only want, well, we will want to filter the types just in case. Or do I? I don't think, oh yeah, because our own section will appear. So the easiest way to filter that is to check the type so that we don't get any hex faces. Okay, so one other thing I need to do here actually is before I even run, I need to make sure that the sections have been generated in every chunk. Let me see, so when this is done, okay, it does say it's complete. I think the best way to do this would be to loop through this twice. All sections complete is true, and then if chunk S sections is, oh, I guess I should check if it's not complete. Okay, so that way we know that all the sections has been generated, so that means the entire placement map is complete as well. Okay, so anyway, back to this. Yeah, so if this is a rect margin or a triangle margin, we'll add it to the list. What did I call it? Neighbors. Okay, and here I should clear the neighbor list. I think I'll do it after I run, actually. I can also just add it, so... Okay, well we have to do a bit first. Okay, so I keep jumping around the code. Right, so what do I want to have here? Well, we'll definitely need the chunk index. and the section and the side. Okay, and since since I got all the neighbors for my specific cell index, that means that this is also my side, so I don't need to try and transform that at all. So I don't really need to put this in here, I don't think. I can just put the section type. Oh. Yeah, it doesn't even use this. And I always forget to instantiate these lists, temporary lists, so I'll be sure to do that there. Okay, and then if it's any other type, we don't care about it. So, okay, yeah, now I just need to sort the neighbors. Okay, and since this isn't a static function, I should cache it here. I don't know if it really matters that much, but that's what I've always done to try and save a little garbage. That's a comparison. So hex comparer. Actually, I'll just call it the same as the function, except with a little s. Okay, so now I'm ready to do this again. So we have the types, and really, well, how are they ordered? I could do it kind of the, I guess, I don't know the right word, but slightly hacky way. Do I not even, okay, I guess section type isn't in this class. Oh, it's right here. Where I just turn this into an index, and then we know rectangles I want first, and they're appear after this in the section type enumeration. So I could do something like int spanning rect or int oh gosh, I can't talk. A dot type minus int b dot type, and then that would return -1 if a, for example, is a rect margin and b is a triangle margin, but I don't know if that's the best way to handle it. Let's see, so type priority. Let's see, private int get type priority. Let's do for hex. I could even just put this priority in this neighbor instead of actually giving it the type. Because then I kind of already know the priority here. Okay, I think I'll do that actually. It's a little, if I can spell it right. It's a little less prone to error, I think. So I'll just do something like if type is spanning rect margin, I'll return 0, otherwise 1. Okay, so makes that simple. So if a dot priority is b dot priority, I need to sort on something else, and so I'll sort based on the side. So then we just return a dot side minus b dot side. So if A is smaller than B, this will be negative, which means A would appear first in the list. That's what I want. And these will never, the parent sides won't ever be equal because there's only one rect margin at a specific side, so that's okay. And if the priorities are different, then we can do this. And if the priority, if A's priority is lower, which it would be if it's a rectangle, then this will be negative, which means A will appear before B in the list, and that's what we want. Okay, so there, that's done. Okay, and now I need to somehow transform these neighbors into get this. Should I, like I wonder if for other margins, if I'm gonna even need this neighbor list, because they probably won't need to be sorted, because they'll have a constant. Well, I guess it probably should still be, because I won't know what order I would find the sections in this placement list. But I think sorting them like this is the easiest way to deal with that. Anyway, section dot neighbor sections is new, and then it's the same size as this neighbor list. Okay, so section, neighbor sections I is a new vector2 int, and x is a chunk index, so I can do neighbors I chunk index and neighbors I section. Let's do that just to clean that up a bit. Okay, so that's not that difficult. Maybe we should test it first to see if this code works. Oh, I spelled this wrong. I forgot the H. Such a weird word. Okay, so now I'll add it to the train mesh systems. Oh, that's not what I wanted to do. Systems, add new neighbor system. Okay. So I think that's all I have to do. So hopefully the list will actually be somewhat coherent. But more likely we'll probably get some errors, which is fine, I guess. We can fix those as they come. Oh wow, no errors. Okay, so let's see. Section 0. Don't care about that stuff now. Okay, well that's not good. It has no... Oh, because the neighbors were set to idle, so it never actually ran. Okay, I forgot to do that. So here I need to change this to neighbor sections, waiting, and I guess I'll go ahead and do the twins for now, even though it's never actually going to run. Okay, so the neighbors did run. It says we only have 5. Well, that actually would make sense because it's this specific one. Oh. So this is chunk 0, section 0. It's on chunk 0, cell index 0. Okay, and it says our neighbors are on chunk 3. Okay, well that's not right. So chunk 3, chunks 1, 3, 5, 2, and 4. Okay, so it's giving me the rectangles of this chunk. Oh, it has cell index 0? Are the cell indexes... Wait. Cell indexes must be local to the chunk. Is that right? That seems weird. Yeah, they are local to the chunk. Okay, that's... makes a little bit of my code hard to use. Okay, maybe that's why I called it hex index at first. Where is this even used? Is it used anywhere? The board index. Okay, so yeah, it does add the chunk to it. Do I even need... Like, I don't... Like, it doesn't seem like it's that helpful to have, like, our index within the chunk. It'd be easier if this was the actual index on the map. Well, especially for what I'm doing now. Because I think this might just be useless. And then it'd be a lot easier to find the hex position because this would actually be the position for this map. So let me see here. So where does this use the cell at all? Yeah, it's always the... Wait. Okay, so chunk index and then the hex. Yeah, so it's not actually used anywhere except when we try to find the board indexes, which would actually be simpler if I just passed in the actual cell index instead of the local cell index in the chunk. And if I ever did need the local index, that would not be difficult to figure out. Okay, so, okay, well, I already have the beginning row and column, actually, so all I need to do is... okay, so this is finding... Okay, so this is finding the local row and the column and the chunk. Is it? What even is this position then? Okay, so this position, is this the actual map position then? Oh yes, okay. So from that I can get the real index. Let's rename this to board position just so I don't confuse myself. I don't really even need to pass that because I could get this from the board index, so maybe I won't. Yeah, it's just row times the row size, so battle board plus the column. Okay, so yeah, I don't, or do I? Yeah, I don't actually use this here, so I think I'll just get rid of that because it's calculatable from um, this board cell that I'm going to pass through, and I don't even need the local index in any of these. Okay, so yeah, I was already using it as a global before, so X position from board index, and I can just pass and the cell index. Okay, so that's how I can get this from the cell index. Hopefully. I think I'm doing these changes correctly. Okay, also I realized I cleared the state placement here. Oh no, that's fine, okay. I was gonna say, and it would clear it every time I run a new chunk. Oh, which that is what happens actually. So this needs to actually clear. Okay, not here, it needs to clear at the very beginning. When we generate the chunks itself, which that happens at this place, at this part. Okay, and I think that's why, because one other question I had is if I was using the local indexes, how come I didn't have neighbors in any other chunk and it was only in the last chunk? That's because I cleared the neighbor map every time I generated a chunk by accident. Okay, so now there's an error. Oh, okay, I forgot to update the board index generation. So all I have to do now, they don't have to call this function because the cell index is actually our global index, so I can just call that hex position um, from board index. Okay, so okay, that should fix that. Yeah, because this was having an error in the position, and that's just because I think the board indexes were shifted. Okay, so no errors, that's a good thing. And my neighbors. Okay, well, this is still not correct because it's saying I have a neighbor here, which is true. That's the spanning or the margin on the north. Or, okay, it's this margin right here. Oh wait, no, I do only have 3 neighbors because this is I don't have the edge of the world neighbors. Okay, so that's good. Yeah, so I just have 1, 2, 3 is this one, and I guess the next one's a triangle at side 1. Yeah, right here. Okay, so this next one should be a hexagon. This one should have 1, 2, 3, 4, 5, 6, 7 neighbors. And it does. Okay, so this right though. It says it has 5, 7. Okay, it does have 2 and 3. Which must be these two. Okay, why does it have 23 though? Probably just because a triangle doesn't get created for a while. Yeah, it's cell index 8, which is this one. And so, yeah, I guess it created that triangle. Let's see. Side 2. Yes, 0, 1, 2. Yeah, so that's it. So I think these look fine. Oh, what's going on there? Why are some of the hex faces not being drawn? That's weird. They stop on the 3rd row for some reason. I don't know. But it's only the hex faces? Yeah, there's no geometry there, so it's not like the UVs are messed up. It's like some of the sections didn't even get created. You see. There's still 88. Okay, so let me try and find another section down here. Okay, so this is hex face at index 15. So this is 0, 8, 16. Wait, so is that right? So how would 15 be here? Let me count. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so somehow the cell indexes got messed up. Why does it only happen on the 2nd row though? Okay, I'm gonna try to find another hex face at 14, so it's still there. Let me see. Maybe I did the... I also wonder why they're just invisible. This looks correct. Okay, let's only create hex faces so that way I don't have to worry about the other sections for now. Yeah, so only 2 rows are created. Oh, but this is all the first section. Okay. Yeah, they're all on top of each other. Same thing with the colliders. I see what's going on. So if I moved this... But I thought that was the whole point of this. Okay, I thought the row and column here were supposed to be the actual... the actual board size. Let me see here. I don't know how this bug couldn't have happened earlier. I guess because nothing actually cared about the... Oh, I'm still passing in the local index here. Okay, that was silly of me. Okay, there we go. I was trying to... I couldn't figure out how that could actually be happening, but... Alright, so now if I re-enable all this, should be fine. Alright, yeah, so everything's back to normal. Okay, so I guess the neighbors are done for now. Oh, well, no, I need to do the neighbors for the other section types. And I kind of have to do them all at once, because otherwise blending normals won't make any sense. Okay, but at least we know it works for hex faces. Let's see, for... correct margin. Okay, so first I gotta do my own, and then I have to do the neighbor, so... So here I'm just looking for hex faces, and then I guess I can also do the triangles. Because I can find the two triangles that are connected to me this way, but... Okay, we've got... This time we'll also have to check this side though, so I can't just add every triangle. But any hex face that's in this list we know already is fine, so okay, we'll make sure this appears first before the triangles. Okay, and chunk index. Okay. Well, yeah, I guess we'd want to use that, but before we add it, we have to make sure that it's one side, a specific side. Okay, so let's open up the diagram so I can get this right. Okay, so if we're at rect 0, then we want triangle 0 and triangle 1. Okay, so we have to make sure that the entry side equals section side, or entry side equals section side plus 1. And then of course we've got a mod 6 so that we will loop around, because side 6 is the same as side 0. Okay, so yeah, either of those we'll take. Okay, also... Okay, let's do it this way. I think we'll sort almost entirely based on priority here, because I don't want to sort just on the side, because I want the triangle that's clockwise to us to be neighbor 0. Or to be... Okay, how I want the sorting is hexagon, our parent hexagon, then the neighbor hexagon, and then the triangle clockwise to us and the triangle counterclockwise, or maybe counterclockwise first, actually. The counterclockwise one would be the one with the same side. So if this is true, we'll do 2, otherwise 3. Okay, and then I'm going to need to loop through again to find the neighbor. The neighbor's X face. Okay, so this will be entries. Okay, and this will be board index is 1, and I need to do modulo by the layer size so that I can just disregard altitude. Guess I'll put a comment there. Disregard altitude to change a board index into a cell index. Okay, and yeah, this time we only care about X faces. And this will be priority 1. We don't really care about the sides here, but go ahead and set it, I guess. Okay, and I'm just going to be a little lazy right now and not worry about caching this function for now. Alright, so let's test this, and then I'll do triangles. Shouldn't be that much more difficult. Although triangles actually have a lot of neighbors, but, well, they have 6, so. Alright. So, okay, that's a hexagon, and this should be a spanning rect margin. Okay, I think it's this one. Well, I guess I could see. Chunk 0, cell index 0, and side 0. So yeah, this one, it should have 1, 2, 3 neighbors. Okay, so element... Okay, that's not right, because it's saying 0, 0, and 3. These two can't be the same. Yeah, it should be 0, and then, I don't know, whatever this hexagon is. But 3 is fine, because that's this triangle. Oh, I'm looping through the wrong list. Okay. Okay, so now it says 0, 19, and 3. So let's check to make sure 19 is actually that section. It's a hex face at cell index 8, so yeah, that looks good. Let's check one more. Okay, well actually 19... That was this one, right? So this next one should be... Here, let's actually do this one, because it will have a 4 set, or 4 neighbors. Now that I... Ooh, okay, I just realized I'm missing a twinned point for these. Let me go to the scene. So yeah, these points actually, they also need to catch these rectangle margins. So that means that a rectangle margin has 8 at most. So 1. Yeah, so I think I'll still do that one, and maybe the triangles next, and then these corners. I also realized that I kind of wanted the sizes of these arrays to be constant to make it easy to figure out which neighbor is which, but for these ones on the side of the map, they're going to be variable anyway. So I'm not sure. I guess I will need to write some special code for that. Okay, but anyway, so I need to get these. Luckily, I don't think it'll be too difficult because these two are the ones that are side that are one different from my side. And then these two are one different on this hexagon. So, okay, let's try to figure that out. Instead of sorting, what else could I... Because if I want the arrays to be in a specific order, maybe I should just set the values in the neighbor sections array, and I can set it to like -1. I think that might actually be better. The sorting is kind of nice, but the issue is it doesn't take into account if I have like variable numbers. Let me see. So here, actually I need to do this too. So a hexagon face, again, should have 12 neighbors. And I'll set them all to be -1, -1 here. Okay, so... Okay, I guess I don't have to go through this thing with the priorities anymore. If the rect margin, this should be an indexes 0 through 6. I should really comment the order here. So we'll have rect side in, and then ... triangle side in is the order in this array. Okay, so the index is just the parent side here, so that's pretty simple. Section, neighbor sections, entry, parent side equals entry chunk. Oh, come on. There we go. And the same type of thing for the triangles, except we'll add 6. Oops, put the space in the wrong spot. Okay, so for the... Okay, I don't need any sorting anymore. Get rid of all this. Yeah, I think... Well, I did like the sorting method, but it just doesn't work because we have to account for edges of the world, which are a little awkward. Okay, so rectangle margin has 8 because it has the 2 hexagons, the 2 triangles, and then the 4 rectangle margins all around it. Okay, and this one, how I want to do it is... Okay, so parent hex, neighbor hex, counterclockwise triangle, clockwise triangle. Okay, And then I guess starting with my parent, which is here. I don't know. Actually, let's start. I don't know the order. Well, from here, the best way would be to go like that, I think. But we start at the parent and then move clockwise around me. Maybe that'd be the best way to deal with it. Yeah, because I start on this triangle. Okay, so yeah, I think I will do that. So, okay, so how do I want to write that in here? So rect on rect counterclockwise from me on parent X. Rect clockwise from me on neighbor. Counterclockwise on neighbor. Gosh, I can't spell this right. Either way. And then clockwise on parent. So let me see if I said that right. Counterclockwise on parent. So okay, so I'm side 0 and I want to get side 5, so that's counterclockwise. And then clockwise for me on neighbor. Again, okay, this is side 4. And then counterclockwise on neighbor 2. Okay, so I think that works. Although I wonder if it'd be better if I just did counterclockwise on parent and then clockwise on parent, then counterclockwise on neighbor. Okay, I think that's how I will do it. So it looks a little weird when you look at it graphically, but I think it makes more sense in terms of the program. So start here and then counterclockwise, clockwise, counterclockwise, clockwise. Okay, so anyway, here, so this is pretty simple. This is just index 0, so section, neighbor section 0 equals no, I do this a bunch of times. I should probably make it a function in case I ever have to change it. To int. So let's say entry to neighbor. What was it? Position registry. Placement registry. Okay, so now I can just call entry to neighbor. That way if I ever have to change something about how this data is stored, it will be easy to update. Okay, so the triangles we only want to get, yeah, if the side is like that. Okay, but first, okay, so if it's, if we have the same side, that means this is the counterclockwise triangle. So that's index 1. Then else if okay, so I do something similar. Oh, I guess I need to get the rectangles too, so I'll go ahead and do that. And it's the same type of thing, I just need to get one that's clockwise or counterclockwise. Okay, and this is 0, 1, 2, 3, 4, and 5. Okay. But I need to loop around, so adding 5 is the same as subtracting 1 when you do a mod 6. You can see that for sure if you subtract 1, but then you never really want to work with negative numbers with modulo because it doesn't work. Well, I mean, you could do it, but it doesn't work how I want to because I'd want it to loop around after you go below 0, but it doesn't. So you could do, and whenever you add the 6, mod 6, that's basically like you don't add anything. So if you combine these to plus 5, you can see it's the same as subtracting 1, mod 6. Okay, and what is the index I said this was? 0, 1, 2, 3, 4, 5, 6, 7. Okay, so clockwise or counterclockwise first and then clockwise. Okay, and I don't want the one that has the same side as me because that is me, so I don't need to store that because I'm not a neighbor. Alright, and then for the neighbor... First of all, I don't need any triangles from this. And that is index 1 is the neighbor hex. Oh, I did this wrong. This should be 2 and 3. Oops. Okay, and then here, I need to make sure... I can't just use my side because I've got to flip it around because we can see I'm side 0 here, but side 3 on the neighbor. So I need to... Okay, so let's see. Side on neighbor equals section side plus 3, and then mod 6, of course, to loop. Yeah, right here. And again, I don't want to check for this specific side because that would be me, and so again, I'm not a neighbor. I should make sure, do I still, when I add them, the sides here, I should make sure that I flip it. Okay, I do. I don't need to sort. Okay, so let's test this, and now they'll always be sorted in an order. Or they'll have a constant position even if we're at the edge of the world, where certain margins don't exist yet. Okay, so here... Yeah, so we have 12, but only rectangles 0 and 1 exist, and only triangle element 7, so that's triangle 2. Yeah, because this triangle doesn't exist, and this is triangle 1. Yeah, because this is due north right here. So let's check another one. Okay, 19, I think that's this, isn't it? Okay, so yeah, here, 20. Yeah, that's right. 21, and why does it skip 22? Oh, it's a triangle. Okay. Oh yeah, and it puts it right here. Side 1, which is that one. That should be 7. An element So this triangle side 2 is number 6. Let's check that. And it's the same as this with cell index 1. Okay, so that's right. Is it? 0, 1. Oh wait, no, cell is 1, so yeah, it's right here. And side 0. Okay, I got it backwards, so that is correct. Okay, so it looks good. Let's check a rectangle margin. Okay, so we have the 2 hexagons, 0 and 19. Which is right. And then it has no triangle here, but it has this triangle clockwise from it, which is 3, which is cell index 0, side 1. And then, okay, so the next we're looking for this rectangle because it's clockwise on the parent. So that's 23. Is that right? This spanning rect margin, cell index 8. Oh wait, no, yeah, we start counterclockwise, so it wants... Okay, I think I found a bug. Cell index 8, side 2. 0, 1, 2. Okay, well this is its neighbor, but it's not in the right spot, is it? Because it should be this one, and this one doesn't exist, so it should be -1. Oh, you know what? I think I forgot to change the indexes here. Yeah, so this should be 6 and 7. Okay, I knew that was going to happen sometime. Okay, so now what's going on? Element 4, yeah, it doesn't exist like I thought, because it's going to look for this hexagon, which doesn't exist, because it's parent counterclockwise. And then this one, it should be parent clockwise, which is section 2, which is correct. It's that one. Okay, and now this one should be on the neighbor hex counterclockwise, so this one, and I think we did check that. So cell index 8, side 2, 0, 1, 2. And then the next one doesn't exist, it should be this one. Okay, so let's check that 23 and see if its neighbors are fine. So first it should have 19, which is the hexagon here. And then it should have this hexagon, which it says is index 4. The hex face, okay, that's right, cell index 1. And then it has triangle, this one at 6. Oh wait. Yeah, that's right. The chunk 0, or cell index 1, side 0. Oh, okay, never mind, it's this one first. Yeah, because it's the one counterclockwise from the neighbor. Or counterclockwise from my parent. And then 3, which should be this one, which I'm pretty sure cell index 0, side 1, so that's right. It's kind of confusing, all these rotations, but you just gotta work through it. Okay, now 21. So this is the one clockwise for me on my parent, and this is its parent, so it should be this one. 21. Yeah, so cell index 8, side 1. And then 1, which should be on my neighbor, the one clockwise for me, which is right here. Okay. And that is cell 0, side 0. And okay, 2, which should be on my neighbor, counterclockwise, so here. Which is 0 and side 1. And then this one should be on the neighbor clockwise, so this one right here. And that is index 1, side 0. Okay, so everything checks out. I want to check one more that's on a cell boundary, just to see if it actually works. I guess this is as good as any. Okay, so hex face, still index 26. 0, 8, 16, 24. Okay, so it's this one, 26. The only one that's in a different chunk is, okay, rectangle, side 5, so this one. And that's chunk 2, index 10. And that's cell index 33. So again, I'm looking for this one. 0, 8, 16, 24, 32, 33. Side 0, or side 2, so 0, 1, 2, or sorry, I did triangles that time. 0, 1, 2. Okay, so yep, that worked. Cool. Okay. So now I just gotta do triangles, and okay, I guess I shouldn't have closed the game so soon. Okay, so I gotta get all... The triangles is pretty easy. They have 0, 1, 2, or yeah, I guess 1, 2, 3, 4, 5, 6. So I guess I'll do it as my parent, and then... Okay, I think for triangles I usually do parent counterclockwise, then clockwise, because that's how the triangle vertices are wound. So I think I'll continue with that, and then I'll start with... I guess the rectangle in between the parent and counterclockwise neighbor, and then go from there. Or the rectangle in between. Doesn't really matter how I do it, I just need to have a specific order. Okay, I guess I should copy this whole thing. Okay, and then rect between parent and counterclockwise, which is counterclockwise to me on parent, and then between counterclockwise and clockwise. Let me see. So here, so it's counterclockwise to me because if I'm side 0, then I want side 5 for that one, and then this one would be counterclockwise to me on the counterclockwise neighbor, and then counterclockwise to me on the clockwise neighbor. So I guess we can just do it like that. But okay, so I don't have to look up the neighbor. Oh well, I guess I will have to because I'll need to get the clockwise hex, so never mind. Clockwise, parent. Okay, so that means I have 6 neighbors. Let's name this to parent entries. Okay, so that's easy, and then I want a rect margin I don't know why the computer's being slow to get sides. And the one counterclockwise to me. And this would be number 3. So basically I do the same thing for the 2 neighbors. And I think this is my side +2. Let me see. So if I'm side 0 here, they got side 2 on counterclockwise neighbor. And I forget, is this board index 1 or 2? I guess I should check. Okay, yeah, it's number 2. It's a little confusing, but I'll just leave it how it is. Could do something that's my section +2 +5, but that's really confusing. Because I'm kind of like having to do math here anyway, but it's fine. It makes more sense this way. Oh yeah, and this should be index 1 and 4. Oh wait, no, this is... Oh yeah, this is 4. Okay, and then one more time. And I think this is +4. Yeah. I could pull this into a separate function. I might as well. Because they're all the same, I think. Okay, so fine. Try neighbors on X. Wait, I don't need the parent entries, that's the whole point. Okay, well I actually messed that up, but I just need to pass in the board index. I guess I need to pass these indexes, so int store hex index and store rect index. Okay, so find on section, and then the board index is just section cell index. Side is, well, my side, so section, yeah, side, that's right. And then 0, 3. Okay, and then side +2. Oh, I did this on the wrong one, but mod 6. Oops, so it's supposed to be a mod, not a 5. Okay, and then this is 1 and 4. Okay, I'll just copy that actually. So this is board index 1, side +4, and 2 and 5. Okay, that's much cleaner. Look, am I missing anything here? So I get the entries with the board index and loop through it, and then I store it in the past. Okay, so I think this looks good. Can't really do that here because for the parent we do a little bit extra. Okay, and then the last thing I need to do is just add it up here at the beginning. Alright, so let's find a triangle, which I remember is element 3. So first should be 0, 0, because it's our parent, and then this one, which I remember 19, and I think 4 has hex face at position 1, so yeah, clockwise neighbor, and then the clockwise neighbor, or counterclockwise then clockwise. And then this rectangle, and then I remember this one is 23 and this one is 2, so it looks good. Let's find another triangle just to test. Oh, okay, cell index 9, so right here, side 0, so this one. Okay, so we got 24, which should be this. So chunk 0, cell 9, so that's right. And then 42, which should be this one. Okay, cell 16, yeah, that's right. And then 47, 17. Okay, and then 46 should be this one. At 16, yeah, right here, side 2, so 0, 1, 2. That's right. And then 44 should be this one. 16 side 1, and 25 should be this one. Actually before me. The 9, which is, yeah, this side 0. Okay, so looks good. Work the first try. Alright, so I think we're done with that. With add neighbor data to templates. Why did I need to do that? I don't think there's... Oh, I see. What I was going to try and do... Okay, I don't think that's needed anymore. Yeah, I was going to try and do this point twin data, but I can just figure it out myself. Yeah, there's something I could actually put in the template because even for sections of the same type, they'll have different neighbors depending on what's around them. So yeah, can't really put anything in the template. I guess I was gonna try to, but wait, wasn't I? Yeah, I think I was thinking I would have like a possibility for every neighbor, but I don't think that's really needed that much. Because the only thing I could do is, yeah, for every possible neighbor and every possible side, I could have like a point map that's already generated. I don't know if that would just be a lot to deal with, so I don't know if it's actually faster to use it. But I guess I'll look into that. So I did compose this should be placements. That's what I just did. So now I need to decompose the section neighbors into twin points. Yeah, okay, and I'm glad that I decided to put this in a different class because it actually turned out to be pretty large. Okay, so now we're at a point chin. Our twin generation system. Okay, so right now I don't care about the templates actually. What does need to be done is just the neighbors. So S neighbor sections, and I think that's it. Oh, this is waiting for me, so this should be twins. I don't really need any other chunks to be complete either, so okay, so I think I'd actually do something like this. Because theoretically I could make this based on a template. It's just I'd have to like somehow store the twins for every possible neighbor, and then I need to like add extra data for what section index that it's inside. So I don't know. That's actually faster. But anyway, let's just start with hex face. So run for hex face. So we already know how many twins it has, really. Well, actually no, because there could be, again, like the edge of the world. So it is, it's okay if this is variable. Okay, because like for this one, like this hexagon has, this point has 1 twin, this point has 4 twins, this point has 1 twin. So normally every edge point or every corner point would have 4 twins, and then every subdivision point would just have 1 twin. Yeah. But we don't have any subdivisions right now, so that makes it a little simpler. Okay, well I guess I'll just have a list, and this will be like the twin builder list. So I'll have a list of vector 3 int, and this will be the twin builder. Okay, and then yeah, after every section I need to clear this. Although I guess first I can turn it into an array. So section twins equals twin builder to array. Okay, so again, for now, I need to figure out so like, yeah, like I said, every corner has four twins. Or no, every corner has 3 twins because there's 4 points there. I guess this. I'm trying to think of a way to make this not super messy. I don't know. Let's just try it. So for int corner equals 0, corner less than 6. Okay, and I do know the way that the neighbors are arranged. That's the whole reason why I wanted them to be in a specific order. So, okay. for a specific corner, 0, I want to get a point in rectangles at side 0, side 5, and then triangle 0. And okay, so because of the way that the points are generated, I already know what index the twin point will be for every one. I think for this one it'll be 0.0. For a triangle, I think it's 0.0. Oh no, 0.0 is the center, so it's 0.1. And then for this one, it's well, it depends on how many subdivisions we have, but it's let's see. So there's 0 and then 1. So if we have 2 subdivisions, we'd have 0, 1, 2, and then 3. So it's just a number of subdivisions plus 1. Okay, so that's not too bad. Let me see. So really, what I need to do... Oh, wrong class. Private void add twin, and then I'll pass the int or the vector to int. Oh wait, no, actually I think I'll do it this way. So I'll pass the section, the neighbor index, and the point index. And so vector to int neighbor equals section neighbor. Oh, forgot the semicolon. And then I'll add to the twin builder. Okay, and how this goes is the chunk index, which is neighbor x, and then the section index, which is neighbor y, and then the point index. Okay, so we'll add twin section C, because I just want the rectangle that's clockwise to me, which has the same side, and then the point is 0. Add twin section C, and then I want the one counterclockwise to me, so it's C plus 5 mod 6. And this point has to do with the number of subdivisions, so it's database metrics x subdivisions. Oh, no, I can't. Okay. I can't do this because the indexes here also depend on whether this section has the same parent as me, because if it's the same parent, then this is true. If it's a different parent, then it's actually flipped. Okay, that makes it a little bit annoying. Okay, but I'll just finish this because this is how it works for same parent. And then for the triangle, it's C plus 6. Actually, I'll do it the other way because that's clearer to me. And then index 1. Okay, so I do actually need to know some information about the other sections, specifically whose parent they have. And for a triangle, I need to know whether I'm clock. Oh, well, no. Do I have to do this? Yeah, because I need to know, yeah, the orientation of the points, which would depend on which hexagon is the parent. So for triangles, I'd have to like rotate around based on that. Okay. So how would what would be the best way to do this? If it's flipped, then okay, this changes from the first point to the last point because it's not just mirrored this way, it's also mirrored this way because it starts here. Yeah, so that would go to the last point in the section. Okay, so let me see. If let's make a helper function. Well, I was gonna say if it has the same parent, but that doesn't actually work because triangles would have 3 possibilities. Yeah, so okay, that's confusing actually. So how would I know, depending on what parent, which one, like how to orient the rotation? Okay, well let's not get too far ahead of myself. Okay, so if state chunks, this is too much. All right, private void get parent. Int vector 2, or wait, it's vector 2 int. Oh, I have to pass myself. Okay, and then I return state chunks neighbor x sections neighbor y cell index. Okay, so if get parent C, our section C equals my parent, then it works like that. Otherwise, okay, what's it not like? Oh, I actually accidentally put void there. Okay, so otherwise we add the very last point. So that would be, oh, well, I was gonna just use this section and then use num points, but don't have access to that and I'd rather not muddy this up with more variables. How many points? Oh, I'd have to do logic to get that actually. Okay, the private section get neighbor. I guess I don't need this. Okay, so clock. Oh no, counterclockwise. Oh no, it is clockwise rect section. Get neighbor. C. Okay, so otherwise I'll just use the clockwise rect section. Number of points. Oh, number of points is on the template. Okay, so state templates clockwise rect section. Okay, so I don't actually need this now. Okay, this is getting annoying because I could have just done state templates int section type, spanning, rectangle margin, num points, -1. I forgot that the layout of points is in these templates, so okay, well this is fine. Not a huge deal. That makes that simpler. Okay, so for this one, it's kind of the same. So if get neighbor section and then C plus 5 mod 6 dot cell index is my cell index. Then we do this. Otherwise, again, it's flipped, but instead I subtract more from this. So let me see. So yeah, it's -1. Okay, so -1 just to go to the first point, and then minus. So if it's 0, if we have no subdivisions, I need to subtract by 2. So yeah, I need one more parenthesis. Maybe a better way would be to add this like that. Okay, and now this was doing the triangle. And the triangle, how would I? Okay, yeah, because I have to like rotate around based on what cell index a triangle is, and I'm trying to figure out how I can know which cell index is which. I really hate that I have to do this. It's just so fiddly. But I feel like I've stumbled on the best way to find these twin points. But yeah, if I ever change the arrangement of points, then I'm gonna have to change the way this works. But the only other way is that I could look in the templates and find out. Okay, but yeah, but this flipping actually makes it even more complicated. Because if I did, like, for example, have a pre-made map for every possibility, first I need to have one for every pair of section types, then one for every side, and then one for every possible parenting change. So for a rectangle margin, just for a hexagon, that'd be 6 times 2, so 12 possibilities, which I guess isn't too bad. And then for a triangle, it's the same, except it'd be 6 times 3, 18. Because if I did that, then I could just kind of loop through the map of all twins, and then I would just add. Oh no, I wouldn't have to. Okay, I wouldn't add anything, it's just in the normal thing I'd loop through that map. I guess no matter what, I still kind of have to have this logic to figure it out the first time, but... So if I did have a system like that, then the section neighbors, it would still find this stuff, but instead of actually storing this neighbor information, it would just kind of store an index in the template for a twin map, kind of. So that might be better, I think. But anyway, so Okay, I don't really know if that helps much. Well, it does kind of help, actually. Because then I would just have a twin map for every possibility neighboring with a triangle. And then I would and then this actually section neighbor system, which would know for sure the orientation of the triangle already. It could just insert the right template to use. So I think that might be better. Where do I want to put that? So I guess in templates. Okay. Oh, I'm way late. Okay, so let's just make serializable. Do I need another class for this? Yeah, I guess so. So I'll have section type, my type, and then type, neighbor type. Could I flip these, I wonder? Like if... Oh, well, no, that wouldn't work because it's mapping from me to my neighbor. So yeah. And then I'll need to have the neighbor side and neighbor same parent. Oh, okay, no, I can't actually do that because for triangles they have 3 possibilities, so I'll say neighbor orientation, like same parent, etc. And then the actual map, which, okay, so for a specific neighbor, we wouldn't have multiple twins for the same point, so I could just have... I guess it doesn't matter. I guess probably vector... Yeah, just having a list of vector 2 ends I guess would be easiest. So this would be my point to the neighbor point. Oops. Okay, so now in the templates I need to have a list. Okay, I guess I actually don't need the section type because the section type is implied by the template. So I just need to have a list of all these twin maps. Okay, so I think this will be easier because I won't have to try and figure out these values because I'll know them when I'm generating the twin map. And then when we generate these neighbor sections, I can actually just use the twin map that's given to me. But I guess, okay, let me think. So what I need, because for the neighbors I actually, or for the normals I'd actually go onto the neighbors and then loop through all of its triangles, and if it has a twin, then I would add that triangle weight to my point. So here I actually need a reference to the twin map to use on the neighbors template. So let's see, twin map on neighbor template. So I can change this to vector 3 int, and I don't need this at all anymore. Okay, so yeah, there's gonna be a lot of errors here now. I guess I don't really need to have a constant number here anymore either, or it doesn't even need to be sorted. Okay, well that's good to know. So I guess I won't try to deal with this now. We'll have to come back. Okay, and I guess to this I need to add twin map indexes. And then, okay, so I need to generate twin maps. Okay, and then from there we'll be able to do the normals. On templates. Okay, so I guess I'll just delete that. It's fine. Okay, well we got a lot done today, and now I know how I'm gonna do it. I'm a little. Well, I was hoping to finish these normals by the weekend, but I should know everything takes longer than you think. But it's okay. We still got a lot done, so I'm not too disappointed. But thanks everybody for coming by and watching. I really appreciate it. I probably won't stream until Monday. We'll see. Like I say, I keep wanting to do the platformer, but today's still going to be pretty busy, so we'll see. But I will be back at around noon Eastern on Monday. Feel free to follow me here on Twitch or Twitter, and you'll be notified when I go live. I also have a YouTube channel if you'd like to catch up on any previous streams. I always try to upload them there. And finally, a Discord server where you can chat with me. I'd love to have you there. But yeah, I'll put links in chat, or you can check out the video description. And yeah, I guess that's it for me. I better go get some lunch, and have a great weekend. Bye-bye.